Hi everyone, and welcome to another nightly TidalCycles video. Um, I'm not really sure what we're going to do this time. Um, kind of the theme of the past several nights. But I think I might try doing some more stuff with urrrr and seek p loop and some of those meta functions that I haven't really done much with. Um, and then we'll just kind of see what happens. Well, so this video is turning out a little different. Now that I understand that the urrrr function doesn't actually do what I thought it did, let's just look at the source code together and talk it through and see if we can figure out how it is actually working and what the limitations of it are. Because I think it's does less than I thought, but that's okay. It's so let's think about it. So urrrr is saying it's time the the outer p, which is the string of the name patterns, and then the patterns and the functions. Okay. So this thing, So it's applying. So it's doing a slow around the whole thing, which we kind of knew it would, right? Then unwrap. We should talk about what unwrap is. Let me see, is it in scope already? Or do we have to? Yeah, so unwrap is, has this type. And it is, we'll get into more about monads at some point, but unwrap is the, basically, one of the things that makes a monad is that you can take, basically you can take a container of containers of data and then kind of unpack the inner containers into the outer container, so you have just one layer instead. So you think of it as like having a big box full of smaller boxes, and if those boxes are sort of well behaved and act like boxes should, then you should be able to open up all the inner boxes, take the stuff out of it, and then arrange it in the outer box, the big box, and pack it in that way. That's basically what unwrap is. It's the thing that lets you take, examples of it are, it lets you take a list of lists and just flatten it out into a single list. It allows you to combine values for like a, like if it's if it's the IO monad, right? Then you would have an IO of A, and then that becomes an IO of A, which is really just, it runs all of the inner actions and sequences them. That's all that means. So let's talk about this. So there's an unwrap, which means that you have a pattern of patterns at some point. That doesn't seem wackadoo. Now, interestingly, let's try and figure this out. Because I don't think it's going to be too complicated. So it's an unwrap, which means that at some point here there's a pattern of patterns. Then the next thing is this adjust. Well, what's adjust? Okay, adjust takes a, let me see. Oh, right. Let's talk a little bit about this $sign operator. Is just the $sign operator. If you look at the type, it's just fmap. It's really just an fmap that's applied on the inside. I'm an old school Haskell programmer. I tend to just do that, which I believe just means the exact same freaking thing. Okay, so there's an fmap here. So yeah, adjust is being fmapped. And what it's doing is taking a pair of whatever this is, and whatever this is, and then applying this function to them. Okay. Then we've got this whole timed values. I'm actually starting to wonder if this is going to end up being longer than I can do in a single video. Let's see if we can still figure out some intuition for what's happening. We've got. See, I just find it so interesting that it feels like the star multiplier is getting ignored, and yet the alternation is working. And those are just baked into this, right? So why would that happen? Let's think. I'm wondering if the reason for it is that we've got this whole transform thing with these rotations and this scaling. And this, the matching is done by doing a fast of t, except where it's t. Huh. Okay, so this is the arrow time. Is the reason why it seems like the multiplication is getting ignored because of the, is it because of the way that this fast is being applied and the slow is being applied on the outside? Is that what's happening here? Because, okay. Oh, you know what might be kind of a fun thing to try here is to just take one of these examples and then rather than sending it here, let's try looking what it is. And let's just put like a single bass drum here instead. Okay. And what's interesting, okay, so let's 4, 2. Huh. Well, I'll be, look at that. Oh, you might not be able to look at that because it's probably too small. Okay. So, yeah, I'm starting to think this actually has to do with, so if we do that, we get, this is a result. Meanwhile, if you do, say that, then you get, this is a result. And similarly, let's see if, so yeah, huh. Huh. So if I run this, okay. Yeah, that's not what I would have expected. And meanwhile, if I just make it, yeah. Okay, so the multiplication is still doing something. And I'm willing to bet. Yeah, I'm thinking this has something to do with the way the scaling factor of fast and slow works. Which I think means if you want the multiplications to work the way you expect, I think you have to do like an urrrr. Think of it as like an urrrr1. Can you do smaller than one cycle? Yes, actually, you can. Oh, this is going to sound weird. Okay, hold on to your hats. It sounds like someone's bass is about to drop, but the bass drops for the Okay. Yeah, so the it's not that the multiplication isn't doing anything. It's a little more complicated than that, based off of what I think is really just an intersection of how the the outer slow and the inner fasts are working. Okay. So that's, I don't know how I feel about that. I think I just kind of expected it to work a little differently than that. Because yeah. See, if I do this, everything kind of gets its right representation. So that's, I know I keep making noises, but it's doesn't help that it's actually a little surprising to me. And see, like now, are you noticing that like it's in a weird way nothing's changing, even though you would expect. Yeah, that's so the reason I was surprised there is because we made the basic bass drum pattern play super fast, right? And yet the like heck times 16 wasn't going into like a higher range the way I would have expected, because like here 16 times 64 should give me something I would have expected. Which just sounds more like what I would have expected is it to sound a little more like which is that's 32 squared, right? Oh my goodness, I'm clearly tired because 64 times 16. Yeah, okay. That's just, Yes, that's 1024. I am clearly very tired. So I would have expected it to sound more like this. Notice how like that's fast enough, it's like in the proper frequency ranges. Huh. Weird. This was a video where I was just going to make music, and instead I've spent a half hour trying to understand why functions did not behave the way I thought they should. I don't know if that's cool or disappointing. But either way, I'll probably stop here, having at least thought about it for a bit and made some discoveries, and just go ahead and upload this anyway. And maybe in the next one we'll get a chance to do something a little more creatively satisfying again. But if you followed along and if you watch this, please tell me what you think. If you think I'm just trying to use urrrr wrong, or what you think about it and all of that. And I'm just super curious. This was not what I was expecting, but tomorrow's another day and another daily video. So we'll get a chance to make some music then. And until then, take care.